Hey there, and welcome back to How'd You Get That? Today we are taking a look at this kinematics problem. If I accelerate in my car from 0 to 100 kilometers per hour in 3 seconds, over what distance do I pass in order to reach that speed? And if I slam on the brakes after having reached that speed, such that my acceleration is now negative 30 meters per second squared, how long will it take for me to come to a complete stop? So the first thing we want to do is convert everything to standard units. So 100 kilometers per hour, after having done some dimensional analysis, I find that that's about 27.8 meters per second. Time is in seconds, so our distance that we want to find is going to be in meters. Later on in the second part of the problem, the answer will be in seconds. So now let's gather our givens, what we know, and figure out what we want to find. In this problem, we know our initial velocity. That's just 0 meters per second because we start at rest. Our final velocity will be 100 kilometers per hour, or 27.8 meters per second. Our time in this problem will be 3 seconds. And our displacement, well, that's actually what we want to find. We don't know what it is yet. We don't know also what our acceleration is, but maybe we don't need that for this problem. So I have an initial velocity, a final velocity, a time, and I want to find a displacement. So this problem is a great candidate for the fourth kinematic equation here. And all I do is just plug in my values. So this becomes delta x is equal to 1/2 v final, which is 27.8, plus v initial, which is just 0, times time, which is 3. Reducing all that down, I get a final value for delta x as 41.7 meters. And that's the answer to the first part of the problem. Now the second part of the problem says, okay, we have already reached that speed, 100 kilometers per hour, or 27.8 meters per second. If I then slam on the brakes such that my acceleration is negative 30 meters per second squared, how long will it take for me to come to rest? So what are the givens in this part of the problem? Well, our initial velocity now is 100 kilometers per hour, or 27.8 meters per second. Our final velocity is 0 meters per second because we come to rest. Our acceleration, we know, is negative 30 meters per second squared, and we want to find the time, delta t. And we don't know anything about the position, but again, maybe we don't need to figure out anything about the position in this problem. So this part of the problem is a great candidate for the first kinematic equation, the velocity function here. This equation involves final velocity, initial velocity, acceleration, and time, all of which we know or want to find. So all I need to do is plug in my values. 0 is equal to 27.8 meters per second plus negative 30 meters per second squared times delta t. Solving for t here, I just subtract 27.8 from both sides and I divide by negative 30. And I arrive at a final delta t answer as 0.93 seconds. So if I slam on the brakes going at this speed with an acceleration of a negative 30 meters per second squared, it will take me 0.93 seconds to come to rest. If you have any questions, leave them in the comments below, along with what you'd like to see on future episodes of How'd You Get That? If you learned something today, hit that like button, subscribe, and hit that notification bell so you never miss another math, physics, or problem-solving tutorial. Thanks so much for watching, and I'll see you in the next problem.